Now, what we're gonna do is we're gonna add all these three new equations, and we'll have this thing, right? Now, if psi3 is a normal coordinate, then what we would have is would have so this thing is psi3 double dot by definition AFT, and we would have k times some multiple, let's say s, some multiple of psi3 here. So this thing should turn out to be s times psi3, right? So this s is some multiple. If that happens, then psi3 is a normal coordinate. Then this equation governing the evolution of psi3 is uncoupled. So for this thing to happen, we need to have x1 would have b minus a, x2 would have a to b plus c, x3 would have b c. Okay, and obviously we have psi3 by definition to be ax1, bx2, x3. Right? So if we equate the coefficients of x1, x2, and x3 on both sides, what we would find is b minus a should be s times a minus 2b plus c as s times b, and b minus c is s times c. Right? Now we know one thing, that is s is b minus a by a, s is a minus 2b plus c by b, and s is b minus c by c. Right, so we have this equation that needs to be fulfilled if we want psi3 to be a normal quadrant. Now consider this thing and this thing, and they imply b by a minus 1 is b by c minus 1, and that is a by b minus 2 plus b by c. Now for the sake of simplicity, we take we let, let's choose a different color. We take a by b to be alpha and b by c to be beta or gamma. We can use gamma. actually this is not B by C, this is rather C by B. So yeah, still needs to change. So this is C by B, that's gamma. Right, so this thing comes out to be 1 by alpha minus 1 is gamma minus 1, which is alpha plus gamma minus 2. Right, so from these two we have alpha is gamma, right? And from let's say this thing and this thing, we have 1 by alpha minus 1 is, as alpha is equal to gamma, we have here 2 alpha minus 2, right? If we proceed, we have 1 minus alpha is 2 alpha square minus 2 alpha. It's 2 alpha square minus alpha minus 1 is equal to 0. And if one solves this thing, they may find that alpha is 1 or minus half. So we have two options, right, where alpha is 1 is equal to gamma, or alpha is minus half equal to gamma. Now alpha is by definition A by B, right, and gamma is C by B. So A by B is 1 is equal to C by B. That also holds here. And just assume B to be B to be 1, right? Then what would have from this equation is A is 1, so is C. From here, let B be 2, then have A is minus 1, so C, right? So we get two elements, one where A is 1, so is B, so is C, and this is basically zeta 1, right? We remember initially the normal coordinate was written like this, the most general form. Here we found that all the three coefficients are 1, so it turns out to be, this is nothing but zeta 1 as I1 to be, I'm referring it to be. But this is new, this is something new. Here we have found A as minus 1, so or I could just do this thing, it will be more convenient. B is minus 2m, so A is plus 1 and C is minus 1. So we have x1 minus 2 x2 plus x3. So this is something new. This is a new linear combination of x1, x2, and x3, and so we take it to be xi3. Now, is this truly a normal coordinate? Well, let's check. All you need to do is we need to take this combination. Well, let's do it instead of saying it out loud. Let's do it. Convenient that way. So we need the three equations. Right? Here they are. So what I'm going to do is do this thing. 1 minus 2 times 2 plus 3. let's see how this turns out. Minus 2x2 double dot plus 3 double dot. This is ft plus k times x2 minus x1 minus 2x1 minus 2x3 plus 4x2 plus x2 minus x1. So this is using the definition of Xi3. This Xi3 double dot plus t plus k plus 3x1 plus 6x2 minus is it 3? Yes, it is 3. Right. T plus k. Actually, we could just use the minus sign here. Minus 3 x1 minus 2x2 plus 3. So this is nothing but sorry, Xi3. So this is uncoupled, and hence Xi3 is indeed a normal coordinate, and we're done. This answers the first question